Okay, bismillah. Right, okay, folks, welcome back. We are looking at the second part of this video series for the paper 2017 paper 1 higher. Give me a second while I just do some settings on there. That's good. Okay, Saleh, join me on question number 9, please. Jules buys a washing machine. Read the question for me, please.
Jules buys a washing machine. 20% VAT is added to the price of the washing machine. Jules then has to pay a total of £600. Why is the price of the washing machine with no VAT added?
Okay, let's start that question. So let's have a look at the key. Let's have a look at the keywords. Jules buys a washing machine. That's not really a keyword. 20% VAT is added to the price of the washing machine. Jules then has to pay a total price of £600. So this is we call this question a reverse question, where they've done the increment at the beginning, and you got to go work it out backwards. So we have the original price of the washing machine, and then we add the VAT onto the washing machine. That gives us 120%. So this question is talking about 120% is equivalent to £600 of value. So we're starting the question. This is the starting point. The starting of the question with this 120% is equivalent to £600. Now we need to find out what was the price of the washing machine with no VAT. 100%. So we want to work at the original, the 100% value. That's what the question is about. So we have to make our way from 120, possibly in 2 steps, to 100%. So how can we get from 120 to 100? Now we're not going to use a multiplier at the moment. I'm just going to use like a nice pen and paper method. So how do you get from 120 to 100?
You do 120 to 20%. So we divide it by 6.
Okay, and then how do you get from 20 to 100?
You times by 5.
You times it by 5.
Then you do the same on the other side.
Right, because it's a ratio question, what we do on the left-hand side, we must repeat it on the, oops, I'm trying to write with the rubber. You repeat it on the right-hand side, so divide that by 6. That gives you £100. Now, this is not the only way. There's many ways you could do this question, many different styles. But obviously, I'm not going to teach you 20 different styles. So you probably think, oh, sir, well, I can do a different way, and I've done this way, and this way is quicker. You know, you're welcome. There's going to be lots of different ways of doing this particular question. And then we have to times it by 5. So what's 100 times by 5?
500.
Is 500. Okay, so it's a nice kind of not too difficult question. Question number 9. But we have to understand our percentages, and we can use a ratio method, or we can use even a decimal multiply method, whichever method you use, as long as it is a robust method and it works well, inshallah. Right, okay, question number 10. Thank you for that, Salia. Okay, Abdullah, question number 10, let's go.
Show that x at 1 times x at 2 at x times x at 3 can be written in the form ax cubed at bx squared at cx at d, where a, b, c, and d are positive integers.
Okay, so when it says show that, it looks like 3 brackets there, can be written in the form ax cubed plus bx squared plus cx plus d. The brackets have all gone. So what have they done to get from here, from the beginning of the question to there? Well, what do we need to do, and what have they done?
Expand the bracket.
Expand the bracket. So when it says show that, that show that means to us is expand the brackets. Now, we don't normally do in school exercises involving 3 brackets. It doesn't mean that they don't exist. If we haven't done them, we're going to learn them today, inshallah. So x plus 1, x plus 2. So Abdullah, can you help us to do this question, and can you break it down for us? So how would we start the question?
First, you just expand 2 of them.
You just expand the first 2, lovely. Yep. So let's just put a green color on the first 2, and then we'll bring the third one along. Or we can even write it in first. We can drag it down the question. So we are going to be doing the green part of the question. Let's actually change to a green pen. Okay, so what's x times by x?
X squared.
X times by plus 2?
2x.
Plus 2x, and then plus another x. That gives us?
3x.
Yeah, so I'm just going to write the plus 3x to keep our working out slimmer, so we're not doing too much. What's +1 times by +2?
+2.
+2. So let's close the brackets and bring the other bracket down as well. So now the double brackets have been multiplied out, and we've encased it in a single bracket. We've encased it in a single bracket, so in order for us to have the question written in the right format for us to do the third bracket. So what do we do now? Give me a second while I just drag this slightly further away. It's just a bit too close for me. Let's drag it down here a bit. That's better. Now what do we do?
You just do the same. So it's x squared times x, which is x cubed.
And then?
X squared times 3x times 3, which is 3x squared.
Okay, let me change the color of my marker pen. So let's go for a brown. So now we're going to do the +3x now.
Yeah, so that's 3x squared again. And
Plus 3x
9x.
squared, add 9x. Okay, that looks okay. Yeah, next.
Add 2x, because 2 times x. And then add 6.
Okay, now can you simplify for me, please?
Yeah, so there's no other x cubed, so you keep the x cubed.
Yeah.
Then you do 3x squared add 3x squared, which is 6x squared.
Yeah, and then?
9x add 2x, which is 11x.
So this is called simplifying, and we are like terms. Okay, so we're going to have here, well, how much is it altogether? 11x.
Yep, add 6.
And then add 6 is standing by itself, and that's the only number there. So we finished that question. Now the question is not asking us for the value of A, B, C, and D, but it wants us to give it in that particular format. Okay, right, are we happy with that question? So we got the, so let me just put the template that they gave us underneath. Actually, let me just grab that, put that underneath. Okay, copy, paste. Let's try to line it up. Well, there you go. So if we were to use a highlight here, so your A value is over here, your B value is over here, your C value is over here, and your D value. So that's the corresponding values. Okay, so A is 1, B is 6, C is 11, and D is 6. But in this particular question, we don't need to actually write down A equals this, B equals, it just means write it in the format which we've done. So when we get down to this part of the question here, you've actually finished the question. Now this is me putting a little bit extra kind of like explanation on there, but that's not required. And you finished at the black line, all done. Now there's no dotted lines down here. We don't need to copy the question down here. So we have got that little bit of leeway in this particular question to wherever we finished there, stop. But I would definitely encourage all students to underline the answer so it stands out for the examiner, so he has no kind of issues with finding where you finished the question. Okay, thank you for that. Okay, question number 11. Let's have Layla. Layla here? No. Eliza, question number 11, please. Okay.
The graph of y equals fx is drawn on the grid. Write down the coordinates of the turning point of the graph.
Okay, before we go any further, remember before when we were talking about functions, when they say y equals f of x, what are they talking about here? Why have they used y equals f of x? Why haven't they actually given us the function here, Eliza? Because they're talking in which terms at the moment? Are they being specific or are they being general?
They're being general.
They're being general. So they're saying like, it's like saying, oh, like, yes, I drive a car. That's like y equals f of x. They haven't told you which car I'm driving. Is it a Vauxhall? Is it a Cavalier 1.9 CDI, whatever? All that detail has been missed out because they want to keep it not generic. So y equals f of x is drawn in the grid. Okay, so that function could be a cubic function, could be a quadratic function, a linear function, a sine function, could be any type of function they want. So that's just general. So don't get confused or bamboozled. Oh my God, what is this f of x? I haven't done that one before. And so this one is actually a quadratic function, nice and simple. Right, write the coordinates of the turning point. What is the turning point? What are they talking about here?
Where the graph starts to curve.
Where the graph actually starts to turn from one side to the other side, which is where?
In the middle.
Which is literally above the word turning point. Okay, so we need to find out the coordinates of that point here. So we need to go up for the x coordinates and go across for the y coordinates there. So what would be the coordinates then?
1 and then -3.
1 and -3. Okay, that sounds lovely. 1 and -3. Okay, lovely. Next part.
Write down the estimates for the root of f(x) = 0.
Now, normally f of x is equal to what? If you look at the above function, and I'll write it back down for you, normally f of x is equal to what?
Y.
Y. I don't know why, but if you look over here, y equals f of x. So at the top, y equals f of x, or f of x equals y. So what's the y value then? So
0.
y 0. Now, so you got to think to yourself, where is y equals 0? Well, y equals 0, I found one point there. Is that the only point that where y equals 0?
Yeah.
Are you sure? Well, give me a ruler from my school books. Okay, right. Let's have Ismail come in, please. Ismail, can you please help us with this? Eliza, under the impression that we only have one point on the graph where y equals 0. Can you elaborate on that for us, please? Ismail? Okay.
Is it x as well?
Oh, we've gone even further. Okay. Yeah.
Is it that side? That one there.
No.
On the left.
Okay. Anybody else, please, in the class, put your hand up. Let's have a look. Let's have a look. Anybody knows?
There, it's 2 right there.
Okay. Right. I'm gonna put all you guys out your misery. Right. Let's quickly tell you before you guys say some kind of crazy stuff.
Wait, what was the question? I didn't hear.
I want to know where else is y equals 0, because Eliza says it's only there where I put the point.
No.
Go on, where else is y 0?
On the x-axis.
The whole x-axis is y equals 0. Okay, folks, if you didn't know that before, please make a note. Eliza, make a note. The whole of the x-axis is the line y equals 0, because if you find any point here, that will be, say, 1.50. The y value is 0. If I put a point here, that will be 2 point something, and the y value is 0 again. So y is always 0 along this line. Everywhere on that line, from -infinity to +infinity, y has the value of 0. So that's actually called the y equals 0 line. The x-axis is y equals 0. So I'm glad we sorted that out. Right, let me get rid of all this other rubbish on there. Okay, and then we can re-highlight it again. Right, okie dokie. Right, let's get my ruler back on, because we make a better line with the ruler rather than me working freehand. Right, let's enlarge that. So basically, when they want us to work out the roots, they want us to find out where the graph intersects the x-axis, i.e., where the y values will be 0. So back to you, Eliza. Right, let's have a look. Let me get a red pen. So which points are they talking about?
The points where the line goes through the x-axis, which would be
the point where the graph cuts the x-axis. Absolutely. So we want a point here. Okay, and we want a point
between the 2 and the 3.
That's right. So now we need to try to read off those values as accurately as we can. So let's zoom in for you. I mean, I know you won't be able to zoom in an exam, but let's try our best to, okay, right. So we got 0, 0.1, 0.2, 3, 4, 5, 6, 7. It looks like halfway between 7 and 8.
Yeah.
So what will that be then?
So 0.75.
0.75. Lovely. Okay, what about the next one? If I zoom in for you. 1, 2, 3, 2.3, 4, 5, 6, 7. Looks like exactly the same thing again on the other side.
Yeah.
So it'll be 2.75 on that side. Lovely. So you put the comma between them. Them are the two roots. Them are the two x values. That satisfies the equation. Next part of the equation. Read the part C for me, please.
Use the graph to find an estimate for f1.5.
It says use the graph. F1.5. Where's F is 1.5? Now, if you look at it before, if I just quickly cut this out here, copy, paste. Normally, what's next to the F in the bracket?
X.
X. So what have they replaced X with?
1.5.
1.5. So we've got to go find X 1.5. So let's have a look. Let's go and find it. So X, we're going along this axis here. Let's take that line off. So we want 1.5, which is here. So what do they want you to do now at that point? They want you to
They want us to work
out the corresponding
values.
Y value for that one. So
Okay.
let's work that out. Okay, so that one was -3. Give me a second. Let me just rub off the green because the green stuff's in my way a bit. Okay, right. Let's draw that line. Let me zoom in a bit. Okay, it's important that you have a nice sharp pencil in the exam. Oops, I'm trying to write with the rubber. That's not very good. Okay, that's the cleanest kind of position I can get it. So now, Eliza, when you're looking at this this axis, what number do you get next? You now be careful. You have to read the graph on the top. Each one was 0.1, 0.2, 0.3. What about coming down the axis? What is each one of these worth? Is it still 0.1, 0.2, or is it something different?
No, it's different.
What is it now? Because you got five little squares between -2 and -3. So what's each one of them worth?
2.
It's worth 0.2 now. Yeah. So you're going down by 0.2 each time. So you got -2.2, -2.4, -2.6, -2.8. -2.8. And they wanted to know basically, so if you put X, is that in, what will the Y value be? And the answer is, the Y value is?
-2.8.
-2.8. Fantastic, lovely. Okay, thank you for that. Give me 1 second while I just do something. Give me a minute. I'm going to hold my mouse. Come on, mousey, where's this stuff? Okay, Asadullah, can you come back in with this, please, on question number 12, please?
Yeah.
Go on.
So find the value of 81 and a half. So you will have to do the square root of 81.
Okay, before you go any further, are you sure you haven't missed reading something?
Oh, it's -1/2.
Ah, that's a good one. Because some students, the way they saw it, they thought it was a misprint. They thought it was this. That was like a big fraction line with a teeny little gap in it. It's not. It's actually a minus sign. So you didn't spot it. Okay, now what does the minus mean?
It's -1/2. So it'd be square root.
So minus means what? What are you going to do to it?
Reciprocal.
So you got on the 81 upside down. Currently, the 81 is sitting on an invisible 1. If you turn it upside down, you get 1/81. The minus has done its job, so it disappears. You don't have the minus left over on the bottom. So what does the half part mean?
So you'll have to square root of 81.
Okay, but when you say opposite, we're not doing opposite. The word, the power, the index half means square root. So I think you're kind of slightly confusing your wording. What you want to say is it's just simply square root. So what does that give us then?
1/9.
Okay, 1/9. Fantastic. It goes find the value of. Now, okay, now normally, don't forget, when you square root something, you do normally get 2 answers, a positive one and a negative one. But for the sake of this particular question, they are concerned about the positive answer, 1/9.
Yeah.
Okay, lovely. What about the next question? What does that mean?
Find the value of 64.
So what does the bottom number mean and what does the top number mean?
You have to cube root it.
So the bottom number is the root and the top number is the
power.
The power afterwards. Okay, lovely. So let's do that then. Let's change color. Let's have a brown. So, oh, no, that's just a bit too fat. That is way too fat. Okay, 64. That's better. Okay, so I'm gonna cube root it first. What do I do next?
So the cube root of 64 is 4.
Okay, so the cube root of 64 is 4, and the cube root of 125 is
5.
5. And then what do you do next?
You square it.
And that gives
So
you what?
16 over 25.
So 4 squared is 16, and 5 squared is
25.
25. Okay, that's lovely. So the answer for that one is 16 over 25. That's done. Okay, that's lovely. Jazakallah khair, thank you for that. Okay, Layla, please can you join me question number 13?
Yeah.
Let's go.
Table shows a set of values for x and y. Y is inversely proportional to the square of x. Find the equation for y in terms of x.
Okay, now I don't know what we've done these kind of questions before. I think we have, where they give you actually a table, not just one set of values. They give you like a whole 4 sets of values, really 4 complete sets of values. So we can pick and choose whichever one we like. That's not a problem. Which one would you like us to choose?
Can we use 1 and 9?
Of course we can. So the x is 1 and the y is 9. Okay.
Yeah.
You can even write that down. X equals 1 when y equals 9.
Yeah.
Okay, lovely. Now, let's look at some more keywords. It says y is
Inversely proportional.
okay, inverse. When we talk about inverse proportional, what comes into the equation that is not normally there? What do we change to the normal? Normally say y is proportional to the square of x, for example, to the square of x. So we're talking about x squared.
Cube,
Okay.
I mean root.
So the moment you mention the word inversely, what's changing in the what I've just written down?
You're doing the opposite, so you're rooting it.
You are reciprocating it.
Yeah, that's okay.
So the word inverse here doesn't necessarily mean the opposite of x squared. I understand what you're thinking there, but the word inversely means the reciprocal of it. Yeah, that's what it means. So we're going to put here now 1 over x squared. So normally it would be y is proportional to x squared if they gave us the same wording without the inverse in there. But now they put inversely, it means reciprocated. So let's simplify that. So y, we replace the proportionality sign with k. K times by 1 is still k over x squared.
X squared, yeah.
Now, what did we say before? What do we call this? This is the
Formula.
which formula?
General formula.
The general formula. So it's like a rough one, which we're going to put some detail into it by working out the k value. So what values are we going to use now to work out the k value? What are we going to? Oops, not the right color. Yeah, we're going to use 1 and
9.
And 9 and substitute them into here in order to work out the k value. So let's have a look. So y is 9 equals k divided by x squared, which is 1 squared. So how do I work out the k from that then?
You bring the 1 squared over and make it a root.
Okay, now what you done that, I like that you done that there. That's good. That's a common mistake made by lots of students. Now let me explain the difference. At the moment, k is being divided by 1 squared. The actual operation here isn't the squared, it's the divide. The divide is the key thing that's been done. Now remember, opposite of dividing by 1 squared is
Timesing
by 1 squared. So the 1 squared part doesn't also get inverted, just the divide part gets inverted because that's what's being done. So try not to end up doing both of them. Don't say, oh, the opposite divide is times and the opposite squared is square root. You're going to get yourself into a bit of bother there.
Yeah.
So, lovely, we got that sorted out, organized. That's good. We're learning from our the mistakes that we're making in terms of what not to do. So 9 times by 1 squared is?
9.
So k is equal to?
9.
Okay, now let me get rid of some of this stuff to make space. And let me just actually shrink some stuff down. because I do write quite big. Okay, and I need space. I run out of space. Okay, folks, right. The next part. Now we're going to make the general formula. Let's just cut that out as well here from here. Let's make it. Okay, this. Okay. Copy, paste. All right, so what does the general formula now become? It becomes our
specific formula.
remember we've done that, so the general becomes a specific.
Yeah.
So the y stays as y. The k has now got a meaning to it.
9/1 squared.
Over 9.
Squared.
Yeah, so y equals 9 over x squared. So now we have now got a specific formula for this question. Now we can answer questions using that formula. Remember, we started off here and we got to here by using the this process on the left-hand side. So it goes find an equation for y in terms of x. So what we need to do, we need to copy that down. Let me grab a black. So we say here y equals 9 over x squared. Done. Next question.
Okay. Find the positive value of x when y equals 16.
So let's copy down that formula again, the one that we've discovered. We got the specific one. Find the value of x. X we don't know. The y is 16, so the y goes here. So 16 goes into there.
Equals 9 over x squared.
Okay, now how do we release the x from that? How do we work out the x?
You multiply 16 and 9.
Now remember one thing, Leila, you cannot solve a fraction, a question with the item that you want to make the subject at the bottom. You never ever solve it on the bottom. You must move it to the top. So the x squared from the bottom right has to go where?
At the top.
And the number on the bottom left has to go where?
At the denominator.
Yeah, that's right. So we call that cross multiplying. The x squared goes to the top, the 16 comes to the bottom. They literally kind of swap places. So let's write it down what it looks like. Let's write what it looks like now. So we should have x squared at the top equals 9 over 16. Now, what do we need to move to work out the value of x over to the other side?
Squared.
And that becomes a?
Root.
Now it becomes a square root, not previously.
Yeah.
So we say x is equal to 9 divided by 16 square rooted, and they're only looking for the positive value. So what's the square root of 9 over 16?
I don't even know. Wait.
Well, the square root of 9 is 3.
Yeah. Oh, 3 over 4.
There you go.
Never mind.
Said like a professional. There you go. Done. So there's that question all done. Use the table, work out the value of k. Then we made the general formula to specific, and then we use that specific formula for the next part of the question. That's normally tends to be the traditional style of a like a proportionality question. Okay, question number 14. All right, Ismail, please join me in this question, please.
White shapes and black shapes are used in the game. Some of the shapes are circles. All the other shapes are squares. The ratio of the number of white shapes to the number of black shapes is 3 to the ratio of 7. The ratio of the number of white circles to the number of white squares is 4 to 5. The ratio of the number of black circles to the number of black squares is 2 to 5. Work out what fraction of all shapes are circles.
I was just laughing there while you reading that, not laughing at you, but just laughing at how much you have to read. So it's just like it's like you're reading a story or something. There's this is this and that is that, and then this is this. There's just so much information there. Now, when you look at this question, Ismail, how much maths do you actually see in the question? I see this much maths.
Yeah.
The rest of it is what?
Words.
It's English. That's right. So that's the new style of the papers now. They're not giving you traditional, like, here's a numeric question, add this, multiply this, work out the square root of this. They're giving you lots and lots of words. They're giving you wordy questions. So we need to be very good at reading the words and understanding what each line, each bit means. So let's do it a bit at a time. So let's look at the first bit. I'm going to highlight it here. So just don't read the whole lot, just read this highlighted part back to me, and let's see how we start the question. Go.
The
Read that
ratio of
part.
the number of white shapes to the number of black shapes is 3, 7.
So let's write that down. So white shapes. So that's, I think that's the master kind of white shapes and black shapes. So we are like annotating now. We're kind of breaking all the English down into smaller like one word bits and this labeling. Yeah, that's the master. Okay, what's the now? Let's give you a different color now for the next one. Read the green one now.
The ratio of the number of white circles to the number of white squares is 4, 5.
So now we're on the left hand side now. So we have the ratio of white circles. So even though I'm drawing it in green, okay, ratio of white circles to the white squares is, what is it? It's 4 to 5.
Yeah.
So we have another ratio running on that side. So this bit is being represented by all of that. Okay, next, what about the now let me change color again. Right, read the blue line first now and understand that.
The ratio of the number of black circles to the number of black squares is 2, 5.
Okay, so let me color code that into blue as well. So the number of black circles, so even though I'm drawing it in blue, black circles and black squares. So what is it now? The ratio is
2 to 5.
2 to 5. Okay, now, so we got basically a one ratio that's been split into two further ratios right now. What's the question asking now? Let's actually get to the actual question. We've understood that so far, mashallah, which is good. What is the actual question? Read that to me.
Work out what fraction of all the shapes are circles.
Okay. Now, out of the black shapes, we have got 7 parts, and 2 of those parts have been identified as circles. So we got part of our answer literally staring us in our face right now. Okay, so that's there. Okay, now if we look at the white shape side, the left hand side, is it as clear?
No.
No, because before the 2 and 5 adds up to 7, but the 4 and 5 doesn't add up to
3.
No, it doesn't add up to 3 exactly. So what we need to look is this. I need to know what proportion. So we got what is, so can you break that down for me, please? So we've got 4 parts out of 5. 4 parts out of 5 are circles, aren't they?
Yeah.
But 4 parts out of 5 of which number?
3.
3. That'll give you the number of white circles. White circles. Okay, folks, by the way, at the moment I'm writing in the margin. Please do not copy me in that. I just need to use as much space as I can to do the teaching stroke, the work with you guys. As you can see here, they've got comments on the sides, on the right-hand side anyway. Do not write in this area. So if you see me writing in the area, don't go home and say, oh, well, sir wrote there for the lesson, so I'm just going to follow sir. I'm just telling you, my writing kind of gets a bit crazy, goes all over the place. So please, when you're doing your work, do not ever write in an area where they've told you not to write in. That's probably going to be where they're going to put some marking down or some numbers or something, some notes, the examiner, and you don't want to be in that area and blocking it. So what's 4/5 sound by 3 then?
5.
Okay, so can we do so 4/5? Sorry, no, hang on a second. I think somebody hasn't spotted the mistake. It's not 4/5. It's actually 4.
Oh yeah, because all the parts.
That's right, because so far there are 9 parts. Nobody picked that up. Come on, rest of you need to be wakey. We see a mistake, spot it straight away. So 4/9 of the shapes of the white shapes are circles. So we're going to work out 4/9 of 3. So can we do any cancelling?
Yeah.
So what does that give us altogether?
4, 3.
4/3. Okay, now, so we got 4/3 white circles, and we've also got 2 black circles. So let's get the right color highlighter. So we got these ones which are white, combine those with the ones which are black. So what will that give us as total? So what is 2 add 4/3?
2 and 4 4/3.
That will give us how much?
10/3.
3 and
Yeah.
yeah. Now the question, so the question is saying work at the fraction. So we know we have 3 and 1/3 circles. I know you think you can't have 1/3 of a circle, but for the sake of argument, mathematically we're going to leave the 3 and 1/3. We're not going to do any rounding off. They want to know it as a fraction. So it's going to be 3 1/3 circles out of how many? How many parts are there altogether in the question?
10.
10 parts. So 3 1/3 of them are white circles out of 10 total parts. So we need to work out 3 1/3 of 10. What's that give us? How do we do that? How do we understand that?
One-third.
So 10/3 divided by 10/1. So the one you'd work that as a fraction. So the answer is 1/3, correct? Thank you for that. But can we get to that answer by our development of our method? So how do we do a division question? Keep.
Change the sign, flip the fraction.
Yeah, so we got to keep the first one, flip the second one, and change the sign.
Yeah.
So we get 10/3 gets kept. The divide becomes times. The 10/1 becomes 1/10. Boom, boom. Cancel, cancel. 1 times by 1 is 1. And 3 times by 1 is 3. Job's done. Okay. All done beautifully. Well done. So that question there was more like, like you're reading a novel if you're a maths person, because there's so much English, so much sentence, but you got to break the sentences down or like do one part at a time rather than getting overwhelmed by the whole thing. Okay, thank you for that. Okay, question number 15. Anaya, please come in on this question, please.
A cone has a volume of 98 centimeters cubed. Work out an estimate of the height of the cone. John uses a calculator to work out the height of the cone.
Okay, no, stop there. That's another part of the question. That's fine. Let's do part A first. Okay, let's have a look at the question, right? Let's look for keywords now. It says a cone. That's a keyword. Volume. Okay, the word volume, good. It has a radius. Okay, all right, let me get rid of that. Okay, right. So we've got a cone, and the good thing is they're actually giving us the formula for the volume of a cone right here, right next to it. Now, I don't know whether they're going to be doing that all the time, but one of the, I think, general themes of the exam boards, they want to start removing as many formulas as possible, and they want you to memorize them. So hopefully it will still be in the exam by the time we do the exam, you do the exam, but I can't promise it will be. So it would be advisable to learn some of these key formulas, memorize them. That would help your preparation for the examination paper. Okay, so work out an estimate for the height of the cone. What does it mean here by work out an estimate? I mean, do they want us to guess it?
Round.
So question number 15, let's have a look. Okay, when they say work out an estimate, what are they talking about? Salih's just mentioned a word that I've heard, and it sounds good. Okay, now I'm going to ask you, Anaya, what do you think the word estimate here means?
They don't want us to go to a direct number.
That's what they want us to use. What numbers then?
Decimals and round it to the closest one.
They want us to round off the numbers, and I call them chunky numbers, numbers which are like easy to grab hold of. For example, like 100 is easy to deal with, but 98 is more complicated to work with. Like mathematically, 100 is a nice number to work with. Now 5.13, what do you reckon we should round that off to then?
5.
Beautiful. And what should we round up 98 to?
100.
Fantastic. Whoops. I knew I was going to press something by mistake. Give me a second. Okay, right. What is going on over here? Okay. Right, so we need to use those values. So when it says estimate, so let's get our formula. Okay, let's grab our formula. Let's rub this off first. Oh, give me a second. Too much clutter there. We copy, paste. Now, we also have pi. Now, that's another value that needs to be rounded. Normally, pi has a value of 3.14, blah, 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 blah. And the calculator is a really, really big, long number. So what are we going to round that one off to then? Anaya?
Oh, 3.14 or 3.
That's it. 3. That's it. Then was our rounded off value. Let me get a green. So we're going to have a nice, lovely 5, a nice, lovely 100, and a nice, lovely 3, which we're going to substitute in the formula rather than the original values. So let's have a go. So we have 1/3 is okay. That's lovely. We don't do anything to that. Pi is 3 now. The radius is 5 now. And the height, we don't know because it was work an estimate for the height. But the volume of the cone, we do know that in the beginning, which we rounded up to 100. So we substitute all the values in, and the only value that we don't know is the height. But now all the numbers are nice and beautiful. They're nice and easy to deal with. So let's see if we can do any cancelling. What can I do with this 3 and this 3, Anaya?
Oh, cancel out.
Cancel them, yeah.
Yeah.
Okay, and what's opposite time by 5?
20. Oh wait, sorry. Minus. No.
Divide by 5.
Divided by 5.
Okay, yeah. Okay, right. So the height. What's 100 divided by 5?
20. Yeah. 20.
Yeah. You need to be confident, girl. You seem really kind of anxious. Don't be anxious. There's nothing to worry about. If you get something wrong, it's wrong. It's not a problem. We'll fix it up. Yeah, it's part of maths, learning maths. Okay, now have you finished it? Oh, I've done a mistake.
You forgot the 5 squared.
Ah, the 5 squared. Lovely mistake there. Why is that lovely mistake? Because that's missed out again lots of times in the exam. So I'm doing, while I'm doing this demonstration, I'm on purposely doing lots of student mistakes, which are done when I'm marking this paper. I see a lot of times the squared sign missed out. So put the squared sign in. So we're moving divide by 25 instead, actually. So we're going to have to quickly change that. 100 divided by 25 is what?
4.
4. And now, what do we have first, Ismail? First answer
20.
was what? 20. Now you got to look at the sensibility of the answer. So you got a radius of 5, and the height is 20. Yeah, and the volume is that. The height looks a little bit out of proportion, actually by a factor of 5 times. So always look at the sensibility of the answer. Go back, check your working out, and it was that little squared sign that was missing. We went back, we fixed the squared sign. So don't always, so if I got an answer of 200, for example, I'll be thinking myself, scratching my head, okay, I got 200, but that sounds a bit big for this question. Got a volume of 100 and the height is 200. So you have to also look at the sensibility of your answer. Is my answer sensible to the values I've already been given the question? Is it like, for example, does it look like too big or is it too small? Then go back and check, and most likely you missed something out as simple as you missed out the square sign, as I did earlier to demonstrate the question to you. So we have a height of 4. Lovely. Right, okay. And I read the next part. John uses the calculator. Read it for me, please.
John uses the calculator to work out the height of the cone to 2 decimal places. Well,
okay.
John's answer or less than John's answer. Give reasons for your answer.
Okay, so you use the calculator to work out the height of the cone to 2 decimal places. So he's using calculator now, so he's not estimating it. So will your estimate be more than John's answer or less than John's answer? Give reasons for your answer. Okay, so what can we say about our question? So we got an answer of 4. So is his answer going to be bigger or smaller? So you go, sorry, will your estimate be more than John's answer or less? So our estimate will be, so right, our estimate will be, so we need to have a more than or less than answer here for question number 15 part B. So 15 part B. Okay, what's happened in the numerator? So in our top part of the question, so we had the 3.14 became 3, the 5 point something became 5. So the top numbers went down. Okay, and then we also have the pi in there as well. Yeah, that's the pi value there. Okay, right. So the top numbers are becoming smaller, and we got a 3 on the bottom. Okay, so now think about it. If you have a normal question and you have it gives you a normal divided by 3, and then the normal gets reduced, what happens to our answer? Will we get a bigger answer or a smaller answer? Now, what did they do at the bottom? Let's have a look. So the 1/3, we left that as 1/3. Okay, no. How did we work out the height? Okay, no, because the height was equal to 100 and it was divided by 25. So this bottom here, this is the 25. That's what we're looking at. The 25 was made smaller because it was originally 25 here. Okay, we're dividing it by 25, and the 100, that one was made bigger. Oh, that's it. That's what we got to look at. What happens when you make the top number bigger and the bottom number smaller? What happens to our answer? Okay, that's the way for us to look at it. So remember, the height was worked out with this calculation originally 100. Okay, let me get a hold of the highlighter. 100, and then we brought over the 25 from here to the bottom. And don't forget, the 100 has been increased because it was originally 98. The 25 has been increased because it has been decreased because we had originally 5.13. So what happens when you do that? You make the top number bigger and the bottom number smaller. Bigger top divided by smaller bottom. The answer is, anybody in the class?
Bigger.
Fantastic. You get a bigger answer. Our estimate will be more than John's answer. Absolutely. Bigger. But here, more than, that's what it means. More than John's answer. Okay, then we have to explain, since our numerator was rounded up and the denominator was rounded down. Since our numerator had been rounded up and our denominator was rounded down. Okay, remember, don't write into the margin place. I'm just running out of space. I'll tell you what, I'm just going to cheat a bit. I'm going to make it smaller. There you go. Don't write in the margin. I haven't written in the margin. Fix it up. Okay, now are you happy with the explanation now?
Yeah.
Because the height was calculated by rearranging the formula and having the radius the volume divided by the radius squared. Now remember, we had tinkered with the volume. We had rounded the volume up. We had tinkered with the radius by rounding it down. So the 100 was actually bigger than what it should have been. The 25 was smaller than what it should have been. So when you have that kind of situation, when you manipulate the top and make it bigger, you manipulate the bottom of a fraction, make it smaller, then the resultant height will then be bigger than what it should have been. So that's the important part here to notice. Okay. Well, let's move on. Question number 16. Okay, let's have, is it break time? Yeah. Okay, let's have a quick break. Let me pause the video. Okay, where's control? Okay, so Layla, can you read question number 16 for me, please?
Okay. N is an integer greater than 1. Prove algebraically that n squared take away 2 take away n minus 2 squared is always an even number.
Okay, lovely. So they said n is an integer. So let's look at the key words there. So n is an integer. So Layla, tell me what do they mean by integer?
Any number can go in that space.
So n is any
Whole number can go in that space.
Okay, and is greater than 1.
Yeah.
So they're talking about 2, 3, blah blah. That's what they're talking about in the question. N is an integer. Now, the next key word is prove algebraically that this expression over here is always an even number. Now, before we start the question, let's have a think about what defines an even number algebraically. So, for example, if you were to say, we say let n be an integer, as they've said, greater than 1. So what's 2n?
Any number, an
2n is a?
even number.
So the way that you get an even number is when you multiply something by 2. You multiply any number by 2, like any odd number, like any odd integer by 2, you will get even. You multiply an even number by 2, you get another even. So the multiplying by 2 is like in itself, is you're generating even numbers. It's like a little factory, mathematical factory that generates even numbers for us. When you have a multiplier by 2 like present in your expression. So before you start the question, you got to have that right in your head. In your head, you got to know, okay, how do I know what an even number is algebraically? An even number is 2n. Anything that has a multiplier by 2 in it. So if something has a time by 2 in it, it is definitely 100% an even number. So let's go ahead and copy this question down. All right, okay, let's get rid of that. Yeah, let's copy that, put it over here. Okay, so we've got n squared, which we leave as n squared, minus 2. Now, what do we do with this bit here? What do we do, Layla, with this bit here, especially that it's got that bit on it there? What do we do with that?
Do you expand it?
You do absolutely expand it. What does n minus 2 squared mean then?
N minus 2 twice.
That's right.
You multiply it by itself.
Okay, now what number is hidden over here invisibly? What number is hidden there invisibly?
1.
1. So that's how you will get a minus 1 there, because minus 1. You must put that in there. Okay, let's multiply out the brackets first, and then we'll multiply by minus 1 afterwards. So what's n time by n?
N squared.
N time by, let's get rid. N time by minus 2.
2 minus 2n.
And then add another minus 2n gives us?
Minus 4n squared.
No, just minus 4 is right. And then what's minus 2 times by minus 2?
4.
Plus
Positive.
4. Yeah. Don't forget when you do this question, it's imperative that you say it's minus 4n, it's plus 4. If you just say 4n and 4, you'll have the equation written there with the signs missing, and then you won't know what to do with it.
Yeah.
You'll create a level of self-confusion, which the students are quite experts at doing in the examination conditions. So let's multiply out the minus 1 now. So we have now n squared. Why is the n so fat? Let's get rid of it. Okay. Right, let's see that. N squared minus 2 minus
1n squared. So just n squared.
And then plus
4n.
And then
negative 4.
Fantastic. Let's start simplifying it. So what's n squared minus n squared?
Nothing.
Okay, then we have here, we have 4n, and what's minus 4 and another minus 2?
Minus 6.
Minus 6. So you have 4n minus 6. Okay, now that's what we've ended up with. So we're gonna have to make a little statement here. So we got 4n minus 6. So why is 4n minus 6 always even?
Because it's two even numbers.
It is actually two even numbers because 6 is even number and 4 times by number is even number is always even since both numbers are even numbers. Okay, and we can also say they are multiples of 2,
Oh yeah, though.
i.e. We can say 4n minus 6 is equivalent to 2 times by n minus 3. So there's our multiple of 2. Done. Oops.
Yeah.
I think I was squeeze the 2 in there. So if you factorize the 4n, it becomes 2 times by 2n and then minus 3. Okay, so that's the kind of language we need to introduce. But you have to know in your head what is an even number in the first place. But that was Masha done really nice. You were a little bit confused before we done the question, but you're much better at it now. Okay, question number 17. Right, give me a second. Question number 17. Right, let's have Salia. Read the question, please, Salia.
There are 9 counters in the bag. 7 of the counters are green, 2 of the counters are blue. Ria takes random 2 counters from the bag. Work out the probability that Ria takes the counters of
Takes one counter.
Takes 1 counter of each color. You must show your work now.
Okay, then so this doesn't look too bad a question. Let's draw ourselves a little tree diagram. So we're gonna have our green counter, even though we're drawing it in red. Never mind. And we have our blue counter. First go, second go, first go, second go. Drawing the tree diagram is not a requirement of this question. It just makes the question a little bit more visual and helps us to see what we're doing. It's not a requirement. They haven't asked you to do, but we're doing it because it will help us to understand the question. That's one of the tools that we have in our toolbox. When you have a probability question, we draw probability tree diagram, especially when it's got nice 2 simple steps. So, inshallah, 2 simple steps. So, Salih, can you help me fill in this part of the diagram where it says green? So probability of green will be what? 7? 7 out of?
9.
And the blue will be?
2 and 9.
Okay, let me change the color for the next one. Now remember, she's taking 2 counters in the bag. What would be the probability of getting the green on the second go?
Will it be 1 and 9?
Now it was 7 out of 9.
6 and 9.
It won't be 6 out of 9, but 6 out of? Because you've taken 6 out of 8. Well done. So here we have to change the fractions on the second part, because when it says 2 counters, because they haven't said put the first counter back, so it's assumed that you know that what they're talking about is 2 counters without replacement. You're not putting the first one back. So it's like anything. If you've got 9 counters, you're taking 1 counter out. You now have 8 counters when you do the next pick out, and you got 1 less green one as well. So it has to absolutely change. 7 becomes 6, and the 9 becomes the 8. So what goes for the blues in Salia here?
It'd be 1 out of 8.
It won't be 1. That will be still 2 out of 8. Because the green parts must add up to 1, remember?
Okay.
Yeah, because that part of the 2 diagram must add up to 1 still. And we haven't taken the blue one out yet. Next one on the bottom, you pick a blue, you pick another blue on the bottom.
So it'd be 1 out of 8.
1 out of 8, and the top one will have to be what?
6 out of 8.
7 out of 8 to make 8 out of 8, remember? Okay, so you don't take 1 from both of them. You'll take 1 from the one that you were taking it out from. Okay, now it says here, work a probability that Ria takes 1 counter of each color. So I'm gonna get a highlighter now. So 1 color of each one. That means you pick the green first, and then you gotta pick a blue. Or he picks a blue first, then followed by a green. And that's the paths of the diagram. Now remember, when you go in this way on the probability tree diagram, you're working across that way, you're always timesing. If you're coming down the probability tree diagram, with calculation, then you're always adding, because this is the AND part, this is the OR part. So we are over here now, probability of green and the probability of a blue equals the first fraction, oh, okay, let's go, 7/9 times by 7/9 times by 2/8. Now the next one will be this bottom one, probability of a blue first and then getting a green for one of each color. So it'll be 2/9 times by 7/8. So let's work out these calculations. So that'll give you 14 on the top. Don't worry about cancelling for the moment, out of
72.
And that one will give you also. Now remember, because our answer requires this part of the answer and this part as well. So this one or this one, sorry, let me use right language. This one or that one. Then we're going to have to do what to them to work out total? Add them to give us our final answer. So if you add up the two circled highlighted fractions, 14/72 plus 14/72, that will give us a total of, that will give us a total of 28/72. And I can rub those lines back out again, and we can cancel that down, and that gives us a value, Ismail, of what? If I cancel 28/72 down, Ismail, what do I get?
It'd be
Ismail's gone to me.
7/18.
7/18.
18.
Okay, now this particular question has actually got a dotted line at the bottom. So please make sure you put the answer there. So 7, so he's divided that by 4, and that's given us the 7/18, which we had over here, which we duplicated and put on the dotted line over here. That's important. All right, that was a lovely question. That wasn't a too bad probability question. But you have to remember, in this particular question, the key bit here was the probability was without replacement. So you didn't put the first counter back in, keeping the fractions the same on the second go. You change the fractions on the second go because you didn't put the counter back in. So without replacement is the type of probability question that we've done here. That's lovely. Okay, question number 18. Okay, right. Ismail, this one looks like your kind of question, something that you've been practicing recently and you've been smashing it to pieces. So question number 18, let's go. Ismail.
A, B, C, D is a rhombus. The coordinates of A are 5, 11. The equation of the diagonal DB is y equals half x plus 6. Find an equation of the diagonal AC.
Okay, first of all, it says the coordinates of A are 5, 11, which I've labeled up. Okay, so we have a x1, y1 coordinates, and it wants us to work out the equation of the diagonal AC. So normally work out the equation of a line. Oops. We normally need to do, oops, what's happening there? On the iPad, I'm touching things all over the place. You will also need an M value. So we need 3 data points like we just been doing recently. So let's draw the straight line DB. Everybody draw a straight line DB, please. So get your rulers out. Oh, I've got an arrow on mine as well. Fantastic. I don't know how that. Okay, all right. I'm going to move it a little bit across. Ooh, that looks beautiful. Okay, that's supposed to be an arrow tip. That's just my, I think I pressed for too long on the screen with my Apple Pencil and it went into an arrow. So we got a little arrowhead for free. Okay, so the equation of that line is y equals half x plus 6 of the DB. Now it says here they want us to work out the equation of the diagonal AC. So let me get a different color. Let me get a pink. Okay. Oh gosh, no. Make sure I'm doing this properly with the ruler. Everybody draw a diagonal AC. Oh, got a straight line this time. That's nice. Oh, I shouldn't have done that. Okay, that's better. Now, so Ismail, tell me what angle do I, oh, no, don't do that. Okay, what angle, I think I'll keep on touching it and selecting it. So what's the angle, what's going to be our diagonal of the rhombus?
Perpendicular, isn't it perpendicular?
Absolutely, it is perpendicular. Because of the shape they're given, which is a rhombus. When you do the diagonals of a rhombus, it's not a parallelogram. Of a parallelogram, it wouldn't be perpendicular, but for a rhombus, because it's based on a square originally, a square that's leaning over, you will get a diagonal because of the properties of that particular shape. So what topic is this?
Straight line.
Straight lines and perpendiculars, yes?
Yeah.
Okay, lovely. So what do we need to do at the moment? So we have a coordinate that the pink light passes to the perpendicular line. So the diagonal line is our perpendicular line.
Yeah.
Okay, so now we know that it passes through 511. The pink line passes through 511, which is good. So we've got a proper full set of coordinates, x value, y value. But what we don't know the gradient of the perpendicular line, the diagonal AC. So how do we do that? How do we go about acquiring the gradient of that pink line? What do we do? First of all, we have to go to the red line. And we have to extract the gradient from the red line. What's the gradient of the red line?
1/2.
It's a half, yeah. So what will be the gradient of the diagonal of which is the perpendicular to that?
-2.
-2, beautiful. Now can you explain to us? That was a nice, sharp, quick answer. How did you get from a half to -2?
Negative reciprocal.
So we have to do the negative reciprocal. So we have to turn reciprocal. Okay, we have to turn the half upside down. That becomes 2/1, and then multiply by -1. Okay. In all, when we do the formula before, we said m times by m dash equals -1. It comes from that. That's the gradient of the red line times by the gradient of the pink line gives you -1, and that's basically the idea that we use for that. Lovely. So we now have the gradient of the perpendicular, which is the line AC, which is -2. So we have all the data that we need. What do we use next to work out the equation of the pink line? Now that we have all the master data that we need, we have an x value, we have a y value, we have the gradient of the diagonal. What do we do now?
Use the y equals mx plus c.
So y minus y1 equals?
-2 bracket. Okay.
Remember this formula? We use it a lot. Yeah. So now we need to literally pop in these three values into our equation. So let's pop them in a pink color.
Y minus 11 equals.
Okay, equal. I'm just going to put the colored bits in first and then put the rest in. What's the m value?
-2.
And what's the x1 value?
X minus 5.
Okay, so y minus 11 equals -2 times by x minus 5. Is that right?
Yeah.
So we are substituting the values that we have acquired from the diagram and the gradient, and we literally substitute them straight in there. We like literally slam them into the formula, pop them in there. Now you're gonna multiply it out for me. Can you type this up for me, please?
So you add 11, so you get.
So should we multiply the brackets first?
-2x plus 10.
And then?
Plus 11. -2x plus 21.
Okay, right. Now I want to just I think this bit here I haven't really made it too clear. It's just like a little bit on the side. I want to rub that out, and I want to just write it again a bit more clearer. I'm not really happy with the quality of that kind of display. Okay, let's get rid of all this for the moment. Let's move this around to the right hand side. Let me grab this. Okay, let's move this over here like that. And let's put in our data values that we've just worked out from above. Let's make a big deal out of it. So we said here, our x1, y1 is going to be 5, 11. And our gradient of the AC, which is the diagonal, which is the perpendicular of the red line, the gradient you just told me was -2. Is that right?
Yeah.
That's better. I feel more happy now. That looks more clean. So we have the x1 value, the y1 value, the gradient of the perpendicular bisector or the diagonal D, which is AC. Okay, the gradient. Okay, lovely. And we have our answer here, and that answer needs to be then duplicated for the examiner's pleasure over here. So he's happy that we put it all in the right place. Okay, and let's enlarge that a bit and let's make that a bit more clearer, because that should be more clear. Y equals -2x plus 21. Okay, so that question looked a little bit kind of. Do you remember the context of our homework, Ismail? We done circle equations. Remember?
Yeah. Yeah.
So in the context that I gave you, it was circles, and in this context, what was the context this time? It was a rhombus.
Oh, wrong, yeah.
It was a rhombus and coordinate a coordinate quadrant. We got the one quadrant of the x and y's, the positive quadrant. Lovely, thank you for that. Okay, actually, I think I should have called you on this one. This one's gonna. Question number 19 is gonna break some backs. Okay, right, right. I need to have for question number 19 the Lion King from the class, because you're going to need to use all the brain power and all the brain cells that you have in your head to get this question right. Any volunteers, can you please quickly have a show of hands, please, which students would like to attempt this question? No show of hands. Ismail, I think this question is yours, mate.
Okay.
Yeah, that's good. Okie dokie, lovely. So read the question and let's start breaking it down and understanding it. Go.
OABC is a parallelogram. OA equals A and OC equals C. X is the midpoint of line AC. OCD is a straight line, so the ratio of OC to CD equals to K to 1. Given that XD equals 3E minus a half A, find the value of K.
Okay, that sounds like a lot, doesn't it?
Yeah.
Compared to the questions that we've done on vectors in our classwork practice, this looks nothing like that. It looks like complete. It's got its own style, literally. It's got its own style. But let's try to break it down, and let's see how well we can do the question. So let's go back. Now let's go back line by line. Read the first line to me.
OABC is a parallelogram.
So what does that mean? What can you do now to the diagram? Can you do any extra labeling or something?
Parallel lines, so AB is equal to OC and OA is equal to CB.
So this is going to be C. And this is also going to be
A.
A. That's the purpose of that first orange highlighted statement. If they're telling you it's a parallelogram, so they're telling you that they've missed out labeling one of the A's and one of the C's. So you have to put that in yourself. So everybody put that in. Okay, next. Read the next OA equals A. We all know that. That's just obvious. Okay, right. Let's read the.
X is the midpoint of line AC. So you draw a line from A to C and then the middle of that is X.
Okay, let's get a ruler. Let's draw the line. Okay, done. That's X. That's the midpoint. Okay, we could actually maybe put like a line here and a line here. Or maybe just put a point there. just to show those lines are equal. I don't know whether that's really necessary, but for the moment we leave that. That's fine. Okay, and what's the next bit? The next bit tells us about the ratio part. That's the bit that we're going to have to unpack by the end of the question. Now, another important part of the question is this part here.
Yeah.
Okay, so where's that on the diagram? So we need
It's
to
an
draw,
extra line.
yeah, we have to draw an extra line on the bottom.
Yeah.
Okay, let's, so we have to draw something that looks like this. Oops. It says O to C and C to D. Well, O to C is talking about this part, and then C to D is talking about that part. So don't worry about the physical size of my triangle. The most important thing is the labeling that we're going to give it now. But okay, let me get hold of a black pen again. Okay, black. Okay, now remember it's telling you that the OCD is a straight line. I thought OCD meant something else. It's telling us a straight. OCD is a straight line, really? Yeah, OCD is a straight line. That's news to me. Okay, so OCD is talking about this line here, basically. OCD is a straight line. Now, they've told us the value of x to d, so we can put that in. So we are more than happy to put that information on the line over here. So this is the arrow that represents the vector xd. Xd is given to us here. So that's going to be 3c minus a half a. Okay. 3c minus a half. So quick note. So Ismail, when we are writing vectors ourselves, what do we do to the vectors to show that they are vectors?
Draw a line underneath.
Draw a line underneath. Now they've used bold. They've used like a bold black letter to represent vectors, but we use lines underneath too, because sometimes it's difficult for us to differentiate between a normal A and a bold A when we write it, because we're not printing it in that sense, and so that can be a little bit confusing. But so we use that format, inshallah. Okay, lovely. Now, right. So which bit's missing for us at the moment? So we know X to D, we know O to C. Do we know what C to D is? This bit here.
No.
That's the bit that we need to work out. Let's get rid of this. Let's leave the highlighted bit on there. Let's get rid of this and this. Okay. So everybody, the highlighted bit is the bit that we need to work out in order for us to do this question here. O to C, we know. O to C is C. And in order for us to work out C to D, we need to know physically what is C to D. I don't know at the moment. So we need to work it out. So let's work it out. Let's have a look. So let's have a look at what we know. We know, all right, let me get rid of some colors. And let me copy something, grab something. All right, okay. Copy, paste. Okay, well, I think we should just do it here. Done. Right, so X to D. What is X to D equal to?
3c minus a half e.
Okay, so give me X to D according to the diagram. So according to the diagram, remember we used to
X
do
plus
roots.
c and c plus d.
Fantastic, lovely. So X to D, which is this one here, this is X to D, is equal to X to C plus C to D. Okay. Now I think I'm gonna write down X to D over here. Give me a second. I just want to make it a bit more clearer. I'm gonna write down here X to D, which is this one, is equal to X to C plus C to D. That's better. I'm just gonna give that a little quick highlight. So this is our starting of our question. And then this part here is the X to D part which they gave us. And this is the part that we are going to be working with in order for us to work out the question. So we know what the answer is. Now, what is x to c? Can you work that out for me?
Yeah.
Well, go on, define it for me.
It's the same as a to x. So you find half of AC.
Yes, so that's the part. So x to c is half of a to c.
Yeah.
Now, what is a to c?
Minus a plus c.
So if I want to go from here, whoops. Oh,
A to O and O to c.
yeah, so if I want to go from A to C, then I got to go this way, that way, and so it'll be half of that. So it'll be minus, was it, did you say a half? Okay, no, we'll put the minus later. It'll be
Minus
a half
bracket.
by minus A.
Plus c.
Lovely, fantastic. Plus C to D, which we don't know, plus C to D, which we don't know, equals 3C minus a half A, which we do know. So we know everything apart from the C to D. The C to D part is the bit that we don't know. I'm actually going to keep that in gray. We don't know the C to D. Let's get rid of this highlight. Let's put the C to D we don't know. C to D we don't know. Okay, right. Now, how do I work out the C to D now then?
Is a minus half a plus half c. You multiply out.
Yes, we need to multiply that first of all, yes. So that'll give you minus a half A plus a half C. And then what do we do to it? We have to then bring it
over to the other side.
Over the other side. So we're now going to have, on this side, it was, what was it again? It was still 3C minus a half A. So we're going to write down 3C minus a half A originally there. Bring over the minus half A becomes a plus half A. And then bring over the plus half C, that becomes minus a half C equals, and that leaves us with CD. Back to our color coding. So the C to D bit we don't know. The C to D bit is what's only left over on the right hand side. The C to D bit is left on the left hand side. Okay, here we go. So Ismail, can you do me like a final level of like a simplifying, please?
Oh, 2c.
So 3C minus a half C is?
5 over 2c.
Yeah, 5 over 2C or
2.5.
there, 5 over 2C. Any one of those answers is good. Now that we know what the C to D is, we can go back to the formula. So we can go back to this bit here. Let me just remove this bit here and bring it back down. Please grab that, copy, paste. There's the formula. Now O to C from the diagram, O to C is what?
C.
And C to D, we just worked to add. What was C to D?
5 over 2c.
5 over 2C. So we got both parts labeled. Now we know what both parts are. So O to C, let me look again, is C. Let me write it in red. And C to D is the 5 over 2C. Now, how do they want us to display the ratio? They want us to display the ratio in which format?
K to 1.
K to 1. So which bit do they want us to make into 1?
5 over 2c.
That's right. How do you make 5 over 2C into 1? What do you do to it? Divided by it?
5 over 2.
You divide it by itself.
Yeah.
So 5 over 2C divided by 5 over 2C gives you 1. So what do you do to the C now?
Divided by 5 over 2c.
Divided by 5 over 2C. What will that give us? That will give us the value of K. So what will that give us? What is C divided by 5 over 2C? Let's do it over here. Okay, C divided by
2 over 5c.
5 over 2C gives us?
2 over 5c.
Okay, I think it just gives us just 2/5. I think the C's will cancel out. Let's have a quick
Oh,
look.
yeah.
Yeah, so that's really C over 1 time by 2 over 5. Okay, I think we're gonna have to think about the C's as 1 rather than 1 divided by 5 over 2, because it's 1c, isn't it? And that's going to be that. I think we'll have to do it that way to do the question properly. So you're going to have 1c, and then you're going to divide it by 5 over 2. So that's 1 over 1. You keep the first fraction the same. You flip the second fraction, you turn the divided into times, and that gives me the answer that you gave me earlier. Okay, so the answer over here is 2/5. Fantastic. Done. Lovely. Okay, are you happy with that?
Yeah.
Right, so this question I would say is completely different style to the ones that we have practiced, but that just shows you that you got to be able to think outside the box. So we had a question where 2 parts were given to us. So if you analyze the question again, so we know this bit here, we know this bit here, we don't know that. So that was gray. So this bit became that bit here, and XC became this bit, which then became this, and that just get copied down. And then we had to deal with that. We had to multiply the brackets. We had to rearrange the left-hand side. That allowed us to leave CD on its own, making CD the subject. And then we put CD back into the ratio, and then we divided it to make that part equal to 1. And then that gave us the right answer. Okay, lovely. Okay. Right, question number 20, solve algebraically simultaneous equations. And then you thought I was being torturing you in the previous lessons by giving you these questions. Okay, Eliza, come and join me, please, madam. You should be smashing these to pieces. Come on, Eliza. Oof, this is gonna be a, oh my guys, this is gonna be a fun one. Okay, Lisa, first of all, are you happy to join me on this question?
Yeah.
Okay, Bismillah, let's go for it. So read the question to us.
Solve algebraically simultaneous equations.
Okay, now they mentioned the keyword here, solve algebraically. So one way is algebraically, another way could be what? So algebraically, just one way you could solve simultaneous equations. What's another common way of solving simultaneous equations?
I'm not sure.
Elimination.
Graphically.
Oh yeah.
So they can draw a graphical view of the circle and the equation, and actually solve it graphically by you then visualizing the points that kind of, what's call it, intersect each other, and then you can drop off the x value, y value, all that kind of stuff. So, right, what's the method that we're going to use for solving this algebraically? What do we do? How do we work out the values of x and y?
I'm not really sure, but
Okay, no, that's no problem. Let's grab one of, okay, let's have Layla. Layla, please join me. I know you can do this question, Layla. Come on. What do we do to the bottom equation? Hint, hint.
You have to rearrange it first.
Okay, lovely. Rearrange and make what the subject?
X or Y.
Yeah, I knew you were going to say that. Fantastic. So take the minus 3x to the side. Y equals?
Y equals 10. Oh, plus 3x. Plus 13, never mind.
What are you talking
I
about?
was focused, never mind, sorry.
Okay, well, come on, get yourself focused, girl.
Yeah, I am. I didn't see the X.
Pull yourself together. Okay, that's equation number 1, which we're going to be using. And this one becomes this one over here. So we're going to call this one equation number 2. Now that we rearranged the linear equation, making y the subject, what was the point of that? What are we going to try to do next that will help us to solve it algebraically? Because at the moment we've got too many things that we don't know. We don't know the x, and we don't know the y. So we're a little bit kind of stuffed there. We're really in a bit of a difficult situation. So we need to get rid of one of the coefficients. Sorry, one of the values x or y. So we're going to get our equation, which is this one. What are we going to do with it?
You get rid of x, eliminate x.
You're going to get rid of y. We're going to substitute 3x plus 13 for y. Now, don't forget y is equal to 3x plus 13.
Yeah.
So we're going to grab all of this, and whenever you see a y, we're going to throw inside there.
Oh, you put it in the other equation.
Absolutely. So we have x squared plus y squared equals 25. And so where you have the y squared, you're going to put in there the value of y. Here's y, here.
It's 25.
Okay, are we happy with that?
Yeah.
Okay, so don't forget, folks, I will also purposely make mistakes in the question to show you common student mistakes. As Asadullah is aware that that's what, what students do. And so please, can you spot them out as soon as I make the mistake? Not mean I necessarily make the mistake, but just in case. So keep your eyes open for common students' mistakes. Okay, what do you do now?
You expand the brackets first. No, you write it twice and then you expand the bracket.
Okay, lovely. Right, okay, now I want to do something. This doesn't look too nice for me. I don't like it. We keep them all lined up. That's better. It looks nice and beautiful now. Right, let's go. Right, let me get slightly thinner pen. Okay, so we have x squared. Come on then, start multiplying that for me. 1, 2, 1, 2. So what do we get?
9x
Squared.
squared, yeah.
Plus?
16x. Oh, you multiply 39x, yeah.
Yeah, and then that same third plus.
And then 39x again.
And another 39x, and then?
And then what's 13 times 13?
That's your 13 squared, like your 12 squared is 144, 13
169.
Fantastic. Equals 25. Now what do we do now?
You kind of like cancel it down. So the 39x's.
Okay, when you say cancel down, you mean simplify, yeah? Like terms?
Simplify it, yeah.
Okay, lovely. Give me a second. Right. Okay, so we're gonna have now x squared. How many? We only have one line. We have these two 9x squared terms. Oops. That gives us, give me a second. Right, okay, that gives you how much?
10x squared.
And then we have these lots of x terms. Oh, and by the way, when you bring the plus 25 over to this side, it becomes a minus 25.
Yeah,
So 169 minus 25 is?
140. Yeah, 144.
So now the 25 on the right hand side has become a 0 now. So because we've moved it over and the 25 has gone back down to a 0. So we have that. Now, what kind of equation do we have here? If I highlight it for everybody in orange and also equal into the 0 format, what kind of equation do we have here?
I've forgotten what they're called, but you have to find the last.
It's called a quadratic equation.
Quadratic, that's it.
Okay, now what can we do to quadratic equation before we start to try to factorize it? What should we do to it first?
Simplify.
We can simplify it by dividing by what?
10.
What will definitely go into it?
Oh, 2.
So if you divide the 10 by 2, you must divide everything by 2. So 10x squared, that'll give you what?
5x squared. And 39x add 2.
So now we need to factorize the question. So we're going to factorize the question using the technique I showed you. Ismail, can you remind us what the technique is? We have to multiply two numbers. We have to find two numbers that multiply, give you the last number, which is the plus 72. And they must add up to give you the middle number after
double smiley something.
Double smiley. Don't forget the double smiley. It's not an official mathematical method in schools and colleges and universities. It's the one that that's the one that works for me, and that I've learned it that way, and that's the way I teach it to my students. So let's have a look. Can you first of all give me the numbers that multiply to give me 72, please? Just give me a couple.
1 and 72.
1 and 72. Next 2 and
2 and 36.
Yeah, and then 3 and
24.
Good. And then 4 and 18, and then 6 and 12. So all these numbers multiply to give you 72. So we've got to pick one of those for the moment, which I'm going to grab in an orange highlighter. That's
9 and 8.
Which one? Oh, you want me to give put another one down? Yeah, 9 times by 8. Lovely. Thank you for that. Okay, let's get back to this now. So, Ismail, which number pair shall I grab that will go into my brackets? Now, take into consideration, we have to put a 5x here and an x here, because 5x times by x is 5x squared. We're reconstructing the 5x squared. Okay, now, so we're going to put one number opposite the 5x, which is going to obviously going to make it 5 times bigger. And we're going to put one number opposite the x, which will make it only the same size. So I need you guys to choose for me the correct factors. Anybody?
Is it 4 and 18?
Yeah, 20 out of 18.
Mm,
No, that doesn't.
Okay, the actual one that we need
Oh, nice.
is that one.
Yeah, you'd get
Oh.
38 with 4 and 8.
What happens now? So where do you put the 3, Ismail? Well, obviously not going to put the 24 here. If I put the 24 here, that's completely the wrong place because it'll be multiplied by 5 and end up on the moon.
By x plus 3.
X plus 3 here and then?
Plus 24.
Okay, back to you now, Layla. So, Layla, can you explain to the class how do we do double smiley?
First, you do 24 times x, which is 24x.
And then?
5x times 3, which is 15x. And then you add them. You get 39x.
So I said we have to look for two numbers that time to give you plus 72 and add up to give you plus 39 after we do a double smiley. And we've done the double smiley, we put the numbers in, we've chose the right numbers, put them in the right place, and the double smiley is correct, plus 39, we've got it.
Yes.
So them are the correct numbers. So we now need to go and do what with that? So we need to get our 5, let's go back a bit. Let's go to, so we got 5x plus 24. And we got x plus 3 equals node. Now, what do we do now with the, how do we work out the value? That's, we need to now solve it. If we factorize it, we need to solve it. How do we solve it?
You're right. 5x, x equals minus 3.
That's the easy one because the opposite of add 3 is minus 3. And this one here, we can say 5x will be equal to what?
Minus 24.
So that means x must be equal to what?
24 divided by 5.
That's now don't worry about changing that to decimal and doing crazy stuff. Just leave it like that. That's fine. That's lovely. X1, X2. So now from our solving, we've managed to work out two values, an X1 and X2. What's missing?
Your Y.
Your Y1 and the Y2.
Yeah.
So to work out the Y1, we're going to use 3x plus 13 from where? From just over here, yeah?
Yeah, the first equation.
Now the x1 value was equal to minus 24 over 5, which we're now gonna pop into here. So y1 equals 3 times by minus 24 over 5 plus 13. So y1 equals, if you multiply all of that out. Okay, give me a second. Okay, so that if you multiply all that out, and we're just gonna do a little bit kind of save a bit of time, I'm going to tell you what the answer is to that. It's minus 7/5. So we're going to go back and do y2 now. Use the same formula, 3x plus 13 from equation number 2. Okay, well, I don't know what that is. Okay, so we get our x2 value, which is here, minus 3. Put that in there. So we got 3. That gives us a total of
4.
Done.
Positive 4.
So at the moment on the bottom, I think they got a line there. So we need to literally put on the, when it says here, solve algebraically the simultaneous equations, we will need to give like x1, y1, x2, y2, because we actually get 4 values for this particular type of question here. So I'm going to write that down now. So I'm write down here x1 equals minus 24 over 5, y1 equals minus 7 over 5, and that's me being a little bit bad there. I've gone into the, I'm just going to move them across. Okay, and then I'm going to choose a different color. And then I'm going to say my x2 is equal to minus 3, and my y2 is equal to
positive 4.
positive 4. Okay, we're gonna have to leave it there for the moment. I think we have got literally one. Yeah, they're gonna take quite a bit of time, but that's okay, mashallah, what we've done for today. So 20 is done, 19 is done today, and 18, and 17, and 16, and 15, and I think we've also done 14 as well, and we've done 13 and 12, and we've done 11 as well, and we also done 10 and also 9. Alhamdulillah, there's quite a lot of work we've done today together, and we made a nice lovely video. Hopefully that video will be uploaded for you guys as well. Okay, gonna stop the recording.